Hi, everyone. So we are starting a new unit. The first lesson is going to be is called "Is there a pattern here?" We're going to be recognizing patterns and sequences. So learning targets is recognize and describe patterns, represent patterns as sequences, predict the next term in a sequence, and represent a sequence as a table of values. If you look right here, this is our do now. If you were not there, or if you were like there but not there, you know what I mean? Then take a look at these things. Take a look at these patterns, or if you can see if they are patterns, right? And see if you could figure out why we made these, right? Press pause. Okay, and it says write the next three terms, right? We did this like even in elementary school, right? Well, what's the next number, right? Same kind of idea. And if you didn't recognize these, everybody knows this one. And if you didn't, that's okay. These are just the months, right? So January, February, March, April, May, June, July, August, September. So what comes next? O and D. Okay, August, October, November, December. And then SMTW, what comes after that? TFS. You're like, well, why? If you don't realize the pattern now, because this is actually not numbers, right? This is actually just letters representing a word, right? Or some words. So S is Sunday, Monday, Tuesday, Wednesday, right? And there we go. And this one, skip counting, right? We've done this in elementary school, probably first grade, kindergarten, I think kindergarten, right? And this one was an interesting one. Not a lot of people got this one right. But this one, remember, this is like 10 times 10. This one was 9 times 9. And this is 8 times 8. Or what we could say simpler, it would be like 7 squared, right? 7 squared is 49. 6 squared is 36. 5 squared is 25. 4 squared is 16. And these are called perfect squares. These will come up again. These are like numbers that people really like. They'll come up again, even throughout geometry and algebra 2. Alrighty? And so on and so forth. And some of the vocabulary words get used to these ones. The sequence, term of a sequence, infinite sequence, and finite sequence. We're going to talk about the first two. The second two are going to be tomorrow. All right, so this was another pattern. Sorry about the whole name here. There should not be there. But what this is Pascal's triangle. This is a really famous triangle. If you have not seen it before, that's okay. And we were trying to look for patterns. And people notice a lot of different kind of patterns, like there are ones all on the outside here. And then 1, 2, 3, 4, all the way to, it just keeps on going up on the sides, like somebody called it like the second rim, right? The outer rim right here and the second rim. I never thought about it that way, but I was like, oh, I like the description. But then from there on out, we're like, I don't know how to get the rest of it, right? So remember, one of the patterns we found was eventually, it took us a little while to get there. So if it's taking you a little while, that's okay, right? So this is 1 plus 4. So we take the two above numbers, and that gives you that bottom number right there. So 1 plus 4 is 5. And the way we get 21 is 6 plus 15, and that would give me 21. And then you would complete the whole pattern that way. All right. The other thing, this is the reason why Mike Kim was over here, was that if you notice right here, the left-hand side is exactly the same thing as the right-hand side, right? So it says 1, 5, 10, 10, 5, 1. See how it's exactly the same? And if you have something like this, 1, 7, 1, 6, 15, 20, 15, 6, 1, right? This is what we called a palindrome. We were trying to figure out what it was. I totally could not remember what it was. Palindrome. So that's, if you write it forwards or backwards, it's going to be the exact same. Like people were saying like race car. Like that's why I was saying like, oh, like I had a friend named Mike Kim, and we realized his name was a palindrome because whether you write it forwards or backwards, it's still going to be Mike Kim. I was like, what? Does his parents know about that? I don't know, but I thought that was funny. But that's what we call a palindrome. Something not related to this, but kind of related to this. But yes, this is definitely a palindrome. Oh, a pyramid of palindromical patterns, something like that. All right, so there it is. And then, and then we went into positive thinking. So these are some, we're gonna be looking a lot into patterns and trying to figure out how to predict them. But for now, we looked at positive thinking here, right? And people notice, oh, there's you just take one out from all the ends, right? And we know as it gets smaller and smaller and smaller. And so it started with 6 on each one, right? And then it went down to 5 on each one, 4 on each arm, 3, 2, and then 1. And then all of a sudden 0, no arms. What do you think is going to happen for the last one? It's gone. No more pattern. It's done. And so what we did here was we just did a term number. So if you notice, I wrote down a 1 here. So this is for the first term, second term, third term, fourth term. Each one of these objects or diagrams is a term. Okay, so if I'm asking for what's the fourth term? I'm looking at the fourth object, fourth pattern, whatever it is. Okay, and so that would be here. And so it had asked us, it says represent the number of dots in each of the 7 figures as a function using the table of values. So we started out with 25, we counted these up and it was 25. And we counted these guys up. So 5 times 4, which is 20, and then plus that 1 in the middle. So it's 21. And then the next one is 17, 13, 9, 5, and then 1. And if you notice right here, we actually do just go down by 4s. We're just subtracting 4 every single time, which makes sense because we remember our pattern was, it was take 1 away from all of the ends, right? It's literally what we did. We just took 1 off and then we got to the next term. All right. So I guess we could have said we just subtract 4 every single time. Oh, here's my numeric sequence. So it's just be 25, 21, 17, 13, 9, 5, 1. And then we would just write that here as a table. All right, so remember the term number is your X and your value number is your Y. So depending on what the term is, what number the term is, that's going to determine our term value, right? So if we're at the 6th term, that means we're going to have 5 dots. We're on the 2nd term, we're going to have 21 dots. All right. And so from here, what we did and what you can do at home is to figure out how to find these different patterns, right? And we did that for all of these. There's like 10 of them. So we're going to come and do these. We did these together. We got these so far, family tree. And if you're like unsure, you could definitely write these in or check these out and see if these are correct. We have Al's omelet and Donna's daisies and coin collecting. And right here we have the numeric sequence. So, you know, it's just like what each number would be on the Y part, right? The bottom part of that table, right? And is it increasing or decreasing? And then here, the sequence description, like this one, remember for positive thinking, begin at 25 and subtract 4 from each term, right? And it is definitely decreasing. It goes 25, 21. Remember these numbers right here that we had just done. And then so for family tree, they had written down, somebody had said in the chat, 2, 4, 6, 8. So it increases and then add 2 for every generation. Okay, so that's how you would do that. So this is the assignment based on your last name. So depending on what your last name is, that's what you're gonna assign. That's what the ones that you're gonna do, and you should be doing 2 of them. All right, and I'm not gonna fill this out yet. We're gonna do that tomorrow. All right, and then we're gonna move on from there. And then your homework, I didn't write it down, but I believe it is number 1. I want to say that, but go check your camps. All right, I'll see you later. Bye-bye.